All right, so we start our new unit talking about unit pricing and the currency exchange. Now, the currency exchange will be the part that will come in right after, but we're going to talk about a lot of the unit pricing and going to bring back a whole bunch of proportions and stuff. Now, within this unit, we have two primary outcomes. The main one, which is basically a lot of stuff when we talk about the preservation of equality. So we'll kind of talk about that. We'll solve some problems, as well as talk about unit pricing and currency exchange. All right, so let's get directly into our notes. It's going to be really quick and short, especially if you've been paying attention. So we've done a lot of this already. Just kind of bringing it back to make sure everyone's really clear. So a ratio is a comparison between two numbers with the same units. For example, 3 parts of green paint is mixed with 1 part of red paint. So 3:1 or 3/1. A proportion is a fractional statement of equality between two ratios or rates. Now, I'm just going to start this rate bit because that's something that we'll talk about a lot later on. So 5/2 equals 10/x. Now, of course, there's multiple ways to do this, but the easiest way is we do our cross multiplication division. Start at our variable, go to the number directly attached, multiply across, and divide by the remaining number. So x would equal 2 times 10 over 5. 2 times 10 is 20. 20 divided by 5 is 4. Yes, I know that I have a lot of space for this. Probably will try and reduce that a little bit for next year, but not something I need to worry about right now. Okay, here's our variable. Go to the number directly attached, multiply across, divide by the remaining number. So x would equal 5 times 1 divided by 2. 5 times 1 is 5. 2 is 2, so 5/2 or 2.5. Sometimes it's going to make more sense to leave it as 5/2. Sometimes it's going to make more sense to put it to the decimal. So let's see some applications to this. Engines that require you to mix oil with fuel to provide lubrication are called two-stroke engines. You'll see a lot of two-stroke engines in relation to like weed whackers. Trying to think of a lot of others. Some chainsaws will have that. Usually, a lot of individual power tools will be a two-stroke engine. A faller at a logging site needs to refill a chainsaw's fuel can. Hey, so a chainsaw is one thing that is a two-stroke engine. The ratio of gasoline to oil that is needed is 40 parts of gas to 1 part of oil. The chainsaw fuel can hold 8 liters of gas. How much oil should be added to the gasoline to obtain the correct ratio? FYI, 8 liters of gas. That means that this must be a pretty big chainsaw. Obviously, if we're at a logging site, you're going to need some pretty large chainsaws. Okay. So 40 parts of gas to 1 part of oil is using this ratio. 40 gas to 1 part oil. If this is saying that we're using 80 liters of gas, we're going to set up our proportion. 40 gas, 1 oil. So when we have 8 liters of gas, we are going to solve for how much oil that would be. And just like we've done before, multiply across, divide by the remaining number. So x would equal 8 times 1 divided by 40. If I'm doing that in my head right, that should be 0.2. I'm just going to check with my calculator to make sure. And of course, I cannot forget my unit. In this case, it's liters. Of course, if you put the entire word, then that's great. Minus 0.2 liters of oil. So when we go to a harder example, Jean-Luc is a builder that has found that he can arrange work cubicles of his employees best if the ratio between the length and the width of the room is 3 to 5 or 3 to 2. If the room is 6 meters long, how wide should the room be? 3 is the length. 2 is the width. So if we set up our proportion, 3 to 2, 6 meters long. 6 meters long is a length. We don't know how wide it should be. Notice how our length, both length measurements are on the top, and the width measurements are on the bottom. So then we just do our multiplication, do our division. Again, keep in mind this only works when we have a proportion where we have one ratio equal to another ratio. Or we'll talk about that tied into rates, but we'll talk about that when we get there. X would equal 6 times 2 divided by 3. 6 times 2 is 12. 12 divided by 3 is 4. So our unit is meters. So if one room is 6 meters long, it should also be 4 meters wide. Another example. Charles works as a cook in a restaurant. His chicken soup recipe contains 11 cups of seasoned broth, 5 cups of diced vegetables, 3 cups of rice, and 3 cups of chopped chicken. This actually sounds really delicious. It's a good thing that you already came back from lunch. He wants to make the recipe at home for his parents. To reduce the recipe yield, he needs to know what the ratios are between the quantities of ingredients. So this is the application to how we can do it. And I'll show you some extension bits in a second. The ratio of vegetables to chicken. Well, it's just 5 cups to 3 cups. Ratio of broth to vegetables. Broth and vegetables is 11 to 5. Ratio of chicken to rice. 3 cups of chicken, 3 cups of rice, which reduce. They both are divisible by 3. Which means it's a 1-to-1 ratio. And chicken to total. There's 3 cups of chicken, and in total, let's see, that's 16, another 6 is 22. 3 to 22. So what that means is a whole bunch of this stuff can be related to help reduce the yield. Because if by chance we only have, so if Charles was at home and he only had 1 cup of chicken, in order to determine how much vegetables he would need, just be 5 over 3. If you had 1 cup of chicken, this is what we're solving. Vegetables on top, chicken on the bottom. 1 times 5 is 5. Divided by 3. We need 1.6 repeated, or that would actually be the same as 1 and 2/3 cups of vegetables. Which then we could continue on. If we had that 3 cups of chicken, and there's multiple ways we could do that, but we could continue this. If we had 1 cup of chicken and 1.3 cups or 1.6 repeated cups of vegetables, how much broth would we need? 1.6 repeated. And that's exactly what you type into your calculator. You type in 1.6 repeated times 11 divided by 5, and you'd fill in your calculator. So you'd actually type in 1.666666666 all the way until you filled your calculator times 11 and divided by 5. It'll work out as 3.6 repeated, or 3 2/3 cups of broth. But this is how we can use these ratios to our advantage. Right. That will allow you to have some fun here.